Hello, my name is Marcus Begla. Today we're talking about the function and application of our planetary roller screw systems, hereafter referred to as RGT. Since 1982, we've been manufacturing RGT for high-performance, environmentally friendly electromechanical drives. Together, we'll now take a look at the different types of RGTs. RGTs are a particularly precise and robust form of linear drive. Their design distinguishes them compared to other linear drives, such as the ball screw drive, short KGT, by significantly higher load capacity and stiffness. This is achieved by their design with threaded planets. The planets serve as rolling elements to efficiently transfer load between the threaded spindle and the threaded nut. Another great benefit of the RGTs is the wide range of thread pitches or leads that can be produced. The multi-pitch thread of the RGT allows total spindle leads from 0.5 mm to 50 mm per revolution. Here are the specific properties. High limiting speed up to 10,000 RPM. High axial load capacity dynamically up to 5,800 kN, statically up to 40,000 kN. High axial stiffness compared to ball screws. High positioning accuracy and repeatability, plus or minus 1 mu. In our portfolio, we distinguish between 4 different designs, which we'll now show individually. Let's look at the RGT type first. Roller screw systems, in the conventional sense, are basically used wherever an electromechanical linear actuator with high precision, repeatability, and high load capacity is required. The RGT consists of the components threaded screw, threaded planets, threaded nut, spacer rings, and the gear rings. The axial load is transmitted by the threaded screw via the threaded planets into the threaded nut. Synchronization of the system is achieved by engagement of gears on the end of each planet and the 2 gear rings. The spacer rings, similar to the cage in a rolling element bearing, ensure equal spacing of the planets around the circumference of the threaded screw. The specific data are nominal screw diameters from 5 to 245 mm, total length up to 10,000 mm at maximum, leads from 1 mm to 50 mm per revolution, a dynamic load capacity up to 5,800 kN, and a static load capacity up to 40,000 kN. The next type is the RGTR. Roller screws with planet recirculation are basically used where an electromechanical linear actuator with high precision, repeatability, and high load capacity with a small lead is required. The small leads or pitches allow very high positioning accuracy while still permitting comparatively high loads. The RGTR with planet recirculation has a mechanical regulation of the planet engagement. Since these thread profiles are usually single or double-threaded, these kinematics make it possible to manufacture screw drives with small thread pitches and yet robust and load-bearing thread profiles. Smaller thread pitches or leads can also be achieved on screws with large nominal diameters. The planets are held in position by a cage on the circumference of the screw shaft, similar to balls in a rolling ball bearing. After one screw rotation, the planets are lifted radially out of the screw thread by cams into a recess in the nutshell. In this recess, the planet is then axially indexed by one thread pitch screw in the threaded nut and re-engaged. The technical data are nominal screw diameters from 8 to 125 mm, screw length up to a maximum of 10,000 mm, lead from 0.5 mm to 5 mm per revolution, dynamic load capacity up to 800 kN, static load capacity up to 3,400 kN. The next type is the RGTI, commonly referred to as an inverted roller screw. Primarily, the RGTI is integrated as an electromechanical actuator in hollow shaft motors. It offers a compact electromechanical alternative to hydraulic and pneumatic linear actuators. The threaded nut can be manufactured according to customer-specific design, depending on the nominal diameter, with a thread length up to max 800 mm. The RGTI, with inverse design, is an inverted version of the RGT. It has basically the same characteristics as the RGT and is also characterized by a high load capacity and positioning accuracy. Compared to the conventional RGT, in this design, the planets on the screw segment are held in position and synchronized by the spacer rings and gears located on them. This inverted design has a smooth, cylindrical spindle extension shaft without a full-length thread profile. This allows the system to be sealed very well on the extension shaft with a rotary shaft seal. The technical data are nominal screw diameters from 10 to 60 mm, leads from 1 mm to 30 mm, dynamic load capacity up to 300 kN, static load capacity up to 650 kN. The fourth type is the RGTRI. The RGTRI is also mainly integrated as an electromechanical actuator in hollow shaft motors. Therefore, it also offers a compact electromechanical alternative to hydraulic and pneumatic linear actuators. The threaded nuts can be manufactured according to customer-specific design, depending on the nominal diameter, with a thread length of up to maximal 800 mm. The RGTRI with planet recirculation also has a mechanical regulation of the planet engagement. In contrast to the RGTR, the indexing of the planet happens within the screw segment instead of the nut. Since these thread profiles are also usually single or double-threaded, these kinematics make it possible to manufacture screw drives with small thread pitches and yet robust and load-bearing thread profiles. Smaller thread pitches or leads can also be achieved on screws with large nominal diameters. The planets are guided by a cage radially by cams into a recess in the screw segment. After one screw rotation, the planets are lowered radially by cams into a recess in the screw segment. In this recess, the planet is then axially indexed by one thread pitch on the screw segment and re-engaged. The specific data are nominal screw diameters from 10 mm to 60 mm, leads from 0.3 mm to 5 mm, dynamic load rating up to 140 kN, static load capacity up to 380 kN. Now let's move on to some application examples. The field of application of all our RGT types mainly includes adhesive bonding and dispensing technology for the automotive industry, civil shipping, batten down the hatches, actuators, stamping and forming machines, hexapod, axis drives and machine tools, drives of servo presses, robotics applications, lock and bridge drives, telescopes, wind turbines, solar panels, high-precision positioning applications of optical instruments in aviation and aerospace technology, valve control technology in the oil industry, drives and kinematics of hexapod robots. We are able to produce almost any type that is technically achievable as long as the internal components of the RGT can still be assembled. Here is a short overview of the size variety of our RGTs. The RGT 5x1, for example, is used for the pick and place function for the computer industry. because very high precision and repeatability are required there. The RGT 245 by 30 is used for presses with press forces of up to 1,000 tons. The RGT 100 by 24 is used for locks and bridges, among other things. That was a short overview of our roller screws. Until next time.